Hello, my name is Daniel Wong, and I'm a research scientist in wireless networking at Telcordia Technologies. I will be showing you today a demonstration of a prototype implementation of MMP. MMP is Micromobility Management Protocol. It is part of an integrated mobility management scheme we are developing and researching at Telcordia Technologies Applied Research. The purpose of this demonstration is threefold. First, I will show MMP working on these machines. Second, I will show mobile IP working on the same machines and how it has some deficiencies. Then, third, I will look at how MMP addresses those deficiencies and overcomes the problems. Before looking at the demonstration, let's look at some diagrams that compare mobile IP with MMP. This diagram shows mobile IP. The gray nodes up here are an abstraction of wired nodes, and this green node down here is a mobile host. This mobile host has its home subnet here and a home agent in the subnet. Now, when the mobile host moves, let's say, to this other subnet, it needs a foreign agent, and it needs to do a mobile IP registration through the foreign agent along this green arrow here to the home agent. The reply comes back to the foreign agent and to the mobile host. And at that point, packets coming from anywhere else in this IP-based network would be routed to the home agent, which would then tunnel them to the foreign agent. And that's how mobility is handled by mobile IP. There are two problems with this. Firstly, the time taken for the home agent, the foreign agent and home agent to do this mobile IP registration could add significant latency to the handoff. And secondly, the route taken by packets coming into the mobile host is not optimal. Now let's look at how MMP handles the same mobility. Again, we have these gray nodes being part of an IP-based network. However, we now divide this network into micromobility zones, one of which is represented here, and then the rest of them are in this macromobility area. While MMP handles movement within the micromobility domains, movement across micromobility domains will be handled by regular macromobility protocols such as mobile IP, SIP, or mobile IP with location registers. The mobile node, again, is at first communicating through base station 1. And now it moves over here to base station 2. And as before, it needs to do some signaling in order to allow the network to update the location information so that it can route to the mobile host. And it does it through this green arrow. This goes up to what is known as the crossover node, marked with an X here. And what happens in the crossover node is that the forwarding cache information there is updated. Previously, the forwarding cache was set to forward packets for this mobile host to base station 1. Now it would be set to forward them to base station 2. So when packets arrive for the mobile host through the crossover node, they would then be switched from the previous path of going to base station 1, now going to base station 2 instead. Comparing this with mobile IP, we see that there are two advantages here, two improvements. First, we have the signaling for updating the location of the mobile host. This is very quick because it only needs to go from base station 2 to the crossover node. On the other hand, with mobile IP, the foreign agent and home agent could be very far apart. There could be significant latency in that signaling. The second thing is that the packets are coming through the crossover node to base station 2 using an optimal path.